Hey, how you doing? Let's have a conversation about how the flow of information impacts an organization's operation. Please join me on this journey of knowledge dissemination. Enjoy the video. How does data become information? When it is put into context, data becomes information when better decision making is made possible by understanding the technical and business applications or implications of the underlying data. There is a word that encompasses this concept: metadata. Metadata is frequently described as data about data. Although that might be literally correct, etymologically speaking, it leaves a lot to be desired. The National Information Standards Organization is a nonprofit association accredited by the American National Standards Institute, ANSI. They identify, develop, maintain, and publish technical standards and recommended practices to maintain information. NISO has a fuller definition of metadata. Metadata: the information we create, store, and share to describe things, allows us to interact with these things to obtain the knowledge we need. Much better. But what does that really mean? The 5 W's and H framework can help us better understand which questions might be useful when thinking about metadata. Who created the data? Who is responsible for maintaining it? Who will use it? What business or legal policies should be considered when handling the data? When was the data created or last modified? Where did the data come from? Where is it currently stored? Why is the organization collecting the data? How is the data formatted? PDF, Word, Excel, PowerPoint, HTML, etc. These are just a few examples, and there are many because metadata is everywhere. In fact, metadata is so ubiquitous, it is necessary to divide it into categories. According to NISO, there are 4 types of metadata: descriptive, administrative, structural, and markup languages. Descriptive metadata is about finding or understanding a resource. Example properties include things such as title, author, subject, genre, publication date. Its primary uses are for discovery, display, and interoperability. Administrative metadata has 3 components: technical, preservation, and rights. Technical metadata is about decoding and rendering files. Some examples include file type, file size, creation date and time, and compression scheme. Its primary uses are for interoperability, digital object management, and preservation. Preservation metadata is for long-term management of files. Some examples include checksum, which is essentially error checking, and preservation event, like saving a document. Its primary uses are for interoperability, digital object management, and preservation. Rights metadata is for intellectual property rights attached to the content. Examples include copyright status, license terms, and rights holder. Its primary uses are for interoperability and digital object management. Structural metadata concerns relationships of parts of resources to one another. Examples include things such as sequence, 1, 2, 3, 4, or placed in a hierarchy. Its primary use is for navigation. Markup languages metadata integrates metadata and flags for other structural or semantic features within content. Examples include paragraph, heading, list, name, date. Its primary uses are for navigation and interoperability. Another organization, the Dublin Core Metadata Initiative, DCMI, supports innovation in metadata design and best practices across the metadata ecology. The Dublin Core identifies 15 metadata elements that fall into 3 categories: content, intellectual property, and instantiation. Content metadata element includes things such as title, the name given to the resource, subject, the topic of the resource, description, a textual description of the content of the resource, type, the category of the resource, such as a home page, novel, poem, working paper, technical report, essay, or dictionary. Source, information about a second resource from which the present resource is derived. Relation, an identifier of a second resource and its relationship to the present resource, used to express linkages among related resources. Coverage, the spatial or temporal characteristics of the intellectual content of the resource. Spatial coverage refers to the physical region, example, celestial sector, using place, names, or coordinates, example, longitude and latitude. Temporal coverage refers to what the resource is about, rather than when it was created or made available, the latter belonging in the data element. Temporal coverage is typically specified using named time periods, example, Neolithic, or the same date/time format as recommended for the date element. Intellectual property metadata elements includes things such as creator, the person or organization primarily responsible for creating the intellectual content of the resource, publisher, the entity responsible for making the resource available in its present form, such as a publishing house, a university department, or a corporate entity. Contributor, a person or organization not specified in a creator element who has made significant intellectual contributions to the resource, but whose contributions is secondary to any person or organization specified in a creator element. For example, editor, transcriber, and illustrator. Rights, a rights management statement, an identifier that links to the rights management statement, or an identifier that links to a service providing information about rights management for the resource. Instantiation metadata elements includes things such as date, a date associated with the creation or availability of the resource. Format, the data format and, optionally, dimensions, example size or duration, of the resource. The format is used to identify the software and possibly hardware that might be needed to display or operate the resource. Identifier, a string or number used to uniquely identify the resource. Examples for networked resources include URLs. Other globally unique identifiers, such as International Standards Book Numbers, ISBN, or other formal names are also candidates for this element. Language, the language of the intellectual content of the resource. The terminology from the NISO and the Dublin Core provides a solid basis from which to begin a metadata management initiative. However, if there is even the slightest chance that a system needs to communicate with other systems, it is a really good idea to take into account the interoperability between systems, present and future, from the beginning. To do so, the usage of a data dictionary is necessary. A data dictionary is used to catalog and communicate the structure and content of data. The PREMIS Data Dictionary for Preservation Metadata is the international standard for metadata to support the preservation of digital objects and ensure their long-term usability. Developed by an international team of experts, PREMIS is implemented in digital preservation projects around the world, and support for PREMIS is incorporated into a number of commercial and open-source digital preservation tools and systems. The PREMIS Data Dictionary has 4 core goals. Support the viability, renderability, understandability, authenticity, and identity of digital objects in a preservation context. Represent the information most preservation repositories need to know to preserve digital materials over the long term. Emphasize implementable metadata rigorously defined, supported by guidelines for creation, management, and use, and oriented toward automated workflows. Embody technical neutrality, no assumptions made about preservation technologies, strategies, metadata storage and management, etc. The PREMIS Data Dictionary version 3.0, the latest version at the time of this video, defines semantic units or properties of an entity. There are 5 main entities in the PREMIS data model. Object, a discrete unit of information subject to digital preservation. Environment, technology, software or hardware, supporting a digital object in some way, example, rendering or execution. Event, an action that involves or affects at least one object or agent associated with or known by the preservation repository. Agent, person, organization, or software program/system associated with events in the life of an object, or with rights attached to an object. It can also be related to an environment object that acts as an agent. Rights statement, assertion of one or more rights or permissions pertaining to an object and/or agent. Other concepts such as object subcategories, relationships between objects, implementation considerations, and so much more are included in the data dictionary document. One other organization that is useful to keep in mind is the Council of State Archivists, CoSA. It is a nonprofit focused on the state and territorial government archives in the United States, 5 territories, and District of Columbia. CoSA facilitates networking, information sharing, and project collaboration among its member organizations to help state and territorial government archives with the responsibilities for protecting the rights and historical documents of the American people. CoSA outlines 5 levels of metadata preservation. Level 0. Little or no preservation metadata is created, captured, or maintained for electronic records. Level 1. Minimal preservation metadata is available to support electronic records in the archival repository. Level 2. A partially conforming ISO 14721 preservation metadata scheme, like Dublin Core, is in place for electronic records in the archival repository. Level 3. A preservation metadata schema is in place that includes a data dictionary that identifies ISO 14721 conforming comprehensive preservation metadata specifications. Level 4. A premise-based preservation metadata schema is in place that is continuously reviewed and updated to take into account new and different types of electronic records that are transferred to an archival repository. At this moment, you might be thinking, okay, Andre, I get it, that sounds nice, it's very interesting, but this all seems a bit extra. I'll pass. And to that, I'll say, not so fast. Why? Trust. In order for KM initiatives to succeed, metadata must be able to integrate with other metadata that might exist in other systems. That is the whole point of interoperability. Fragmentation and changes in technology can complicate efforts to getting a complete picture of all the organization's metadata related to critical processes. This metadata overhead inevitably slows down decision-making. If the process for managing metadata is done carefully, it can prevent a wide opening for competitors to improve their own data governance initiatives that develop agility and precision where you are sluggish and ambiguous. In a fast-paced environment where the luxury of time might not exist, investing in proper metadata governance will pay dividends by providing operational efficiency that will be a competitive advantage in and of itself. Think of metadata like the submerged part of an iceberg. The information that you think you know is only the surface of the organization's intellectual capital. To find a treasure trove of hidden knowledge, you must go deeper, underneath what's immediately visible. Fortunately, there are many tools and approaches to metadata management. So which ones should you choose? Well, that depends. I'll end this video with what may perhaps be a terrible attempt to verbalize a meme. I don't always go meta, but when I do, I prefer wisdom be acquired through knowledge based on information synthesized from rich contextual data about data. Thank you for watching. I encourage you to provide feedback and participate in this conversation. Comment, subscribe, like, visit my website, let me know what you think. I'd love to hear other perspectives because knowledge is for everyone.